Let's take a deeper dive into simplifying radicals. So the essential question for today is, what if I have square roots that are multiplying or dividing each other? That's what I can do, and I hope that in 50 years when you look back at this lesson, you'll be this guy. Example of something that we did yesterday, this is a little bit easier. Remember, the whole idea of simplifying square roots is that I can split them up, right? So this I can split up into the square root of 9 times the square root of x cubed if I wanted to, because I know that the square root of 9 is 3. And then also this square root of x cubed, maybe I could write it like x times x times x. And since I have a pair of x's, the square root of x times x is just x. Now this guy doesn't have a pair, so he gets left under, and here's my fully simplified square root. So let's apply that to what we're doing today, which is when two different square roots are multiplying each other. Now let's think about this. If I can split square roots up, doesn't it make sense that I could also put them back together, right? So if I have two square roots that are multiplying each other, I can put them back together under the square root. And oh look, this is a pair of 6's, and the square root of 6 times 6 is just 6. And this should make a lot of sense. If you don't like thinking of the pairs, remember that 6 times 6 is 36. And what's the square root of 36? Oh, 6. So it makes a lot of sense. Here's a more complicated example, because notice that I have something outside the square root. So does it make sense that when I multiply this square root and this square root, this guy would just stay outside? I can rearrange it if I want. It's multiplication. So I can do it in any order I want. So if I want to put the 4 over there, just so it's very clear, hey, this is outside, I can do that. And now, like I said, I can multiply these two together. So that would be 12x squared. Let's just factor tree this real quick. This is 4 times 3. This is 2 times 2. So that would give me 4, still outside the square root. I have 2 times 2 times 3, and then there are 2 x's under the square root. So if you like using the pair things, here's a pair. The 4 is already outside. Now it's joined by a 2. Here's a pair, so joined by an x. Root 3, that's the only thing that does not have a pair. I can clean this up a little. 4 times 2 is 8, and then I have an x, and I have a root 3. So I guess the lesson here is leave what's outside outside. You can multiply what's inside together, like I did from this step to this step. Next example. Okay, so here again I have something that's outside, so that's going to stay outside. And I have some things that are inside. Now here's the issue. I don't feel like doing 21 times 7. I can't do that off the top of my head. Actually, I can because I'm good at math, but not many people would be able to just do this off the top of their head. So let's try this strategy. Maybe instead of multiplying 7 times 1 together, maybe we can try breaking it down first. So I know that this is 7 times 3. I know that this is y times y. I know that this is x times x. Isn't it true when I multiply all the stuff in here with all the stuff in here, couldn't I just write it like this? Take a look at what's going on. From this square root, 7 times x times y times y. From this square root, 7 times 3 times x, all under the square root. Now, is this any different from what I did on the previous slide? In the previous slide, I multiplied these together, but then I had to break it down anyway, and I resulted with all these different factors. Couldn't I just break it down first and then write all the factors here? I've saved myself the step of multiplying everything together. Now we may need to just rearrange some things. For example, I'll write the numbers in order, 7, 7. I think I have 3 total x's. But the point is, if I break down first, that's just about the same, and it'll actually save me work. Now, even despite me saying that, I know that very few of you will break things down first. I tell students every year to break it down first, but I don't know. Maybe you guys will listen. My Algebra 2 students didn't like this. They always took this long way of multiplying and then breaking down. Just break down first. It's so much easier. Anyway, all right, so now we're looking for pairs. 7 times 7, so there's already this 3 outside. This 7 times 7, we have a pair of x's, we have a pair of y's. What's left under the square root? We have this 3, and we have this x. So let's just clean it up a little bit. 3 times 7 is 21. Then I have xy root 3x. All right. Let's move right along. Ooh, dividing. Now, just like I can kind of distribute with the multiplying, does it make sense that I could distribute with the dividing? I mean, if I can distribute with multiplying, multiplying and dividing are basically the same operation, just backwards. So I should be able to distribute while I'm dividing as well. So on top, 13, can I factor tree this at all? I think it's just 1 times 13. So there are absolutely no perfect squares up there. So we will just have to leave it as the square root of 13 on top. But on the bottom, I have the square root of 100, which I know to be 10. So this is a little more simplified because since I distributed, I was able to take the square root of 100 on the bottom. Nice. So let's do that same thing here. Let's distribute to the top and the bottom. Now the bottom is easy. The square root of x squared, we know that that's just x. Why? Because there's a pair here, and I know that when I take the square root of a pair, but also because the square root and the square cancel. That's good. Now 28. I know that 28 is 4 times 7. So let me do this problem the non-pair way. I'll just leave it as 4 times 7. Since I know that 4 is a perfect square, the square root of 4 is 2. And I have 2 times the square root of 7. No square root of 7. So here's my final answer. And that's it. This video was really easy. Summary, if you're multiplying, you're allowed to multiply what's outside the radical, and then you can also multiply what is inside the radical, right? So I can multiply everything under the radical together, just leaving the outside stuff outside. If I'm dividing, I'm allowed to distribute that division to the top and the bottom. All right, thanks for watching.